Hello guys, today we're going to be talking all about orthographic projection. I feel like this is a topic that's often not covered very deeply in a lot of tutorials, so I wanted to spend some time on it. And within our code here, which is going to be up on GitHub, I've made a little 2D game, and it looks a little something like this. Very straightforward. We have our player over here, and we have just like a little level with something to jump over, and we have an end goal over here. A and D are the move keys, spacebar to jump. So there's three different states of this game. There's either you're playing, which means you can move around and jump and collide with stuff and stuff like that. And it's a little buggy. I just custom wrote this colliding code real quick, so there's some weird things like you can, there's a lot of logic to write. So we'll go through it here in a second. But so you can be playing, or if you fall off an edge, you lose and you get this X for 3 seconds and then it resets. And if you actually get to the goal without falling, then you get a little green check mark and you win, and then it resets again. So that's all it is. Pretty straightforward. It's just a sample of how you can get a 2D platformer going, because of course in your code, if you're doing a real game, a real platformer, you probably use textures and stuff, but you could essentially get away with using all of this. I've got a little gravity going there too. Let's talk about this orthographic projection and what you need to know. Now, where do I start? Actually, I want to do a few things. I want to add a new folder called 2D game and just put all this code that is specific to the game in there, because it's not really part of the rest of, I guess, what we would call the engine. So now in our main, we probably have to fix a few things. 2D game, there we go. That should take care of it. Okay, that way we kind of have our game code sorted out in its own folder. All right, where to start? Oh, there's so much. I guess I'll just dive right into it and keep going. Starting from the main, let's flip through it. I've added a few new things. Some are relevant, some are not so relevant. I've added like a ortho near and far. I've also added the last viewport width, and it's going to save. So anytime we hit the callback and do a resize at the end, it's going to just remember those. That way we don't have to call GLFW functions to get the window width and height anytime we need them. We just have them available. I'm not even sure if I'm actually using that, but I was planning on it when I was making that little 2D game. Then I kind of abandoned that and just hard coded it in. Let's see, a little prep here. All right, now this is where it gets tricky, because when most places when you look up ortho, they basically just tell you to use like a -1 to 1 on the screen edges, top and bottom, like -1 1 -1 1, or they tell you use like 0 and then your screen width, and then 0 and then your screen height. I think I'm doing that right. That's how they usually tell you to do it, but I didn't really find much luck with that, and I was digging into some resources about making 2D games. One of them was like all in JavaScript and about making web 2D games. So basically what you actually want to do when you are using ortho, if you want like your coordinate system to match properly with your screen size and for things to appear where you logically put them, and your objects to be sized logically with your screen size, like if you have a 1080 wide screen and you make an object that's I don't know, 540, it will actually be half the size of your screen. So this is just a way to do that, because if you're programming from like the -1 to 1, you have to translate everything you're doing into that space, and it becomes really weird with ortho in my opinion after a while. So I kind of like this literal screen size method, and that's what I'm completely using to do this little game that I showed you. So you want to store the aspect ratio. That's important, which is just your window width divided by your window height, and you do need to turn that to a float, because by default those are integers. So you're going to need that, because we're going to need to get these variables. There's something called a half height, which apparently is also in the world of computer graphics called the ortho size. And to get the ortho size, you take your current window height and divide it by 2. And then to get what they're calling the half width, you take half of that height that you ended up with from the first one and times it by the aspect ratio. All right, so that's a little prep to upload that. I think we're using this like down here, so I could move that down a little bit and it should be fine. So Notably, we also do have to recalculate these anytime we resize the window. So in our callbacks, under our frame buffer size callback, we do actually do this again. Yeah, here's the same code again. So with our new width height. So we do have to recalculate this on window size. Keep that in mind. That's in there. All right, very good. So let's continue. So we set up a new 2D shader. So this 2D shader is using a few new shaders. We have the projected 2D, and we have it with this projection view and model matrix. That way we can move it around. We're not actually using the view matrix. It's just staying in identity matrix again. And the projection matrix is the one we're setting to that ortho. And of course, our model matrix is what we're using to move our players around and set things in the world. So if we need to shift things around, we use that model matrix. And I just made a colored frag, which is just very basic. It just takes a uniform of color. That way we can change it on the fly. As you saw in the game, there were different colors of objects. So those can be just changed on the fly with our game logic. So we could literally change any of these or whatever we wanted to do. But I kind of like these basic colors just for starter. All right, so let's close that again. Yeah, so those are the new shaders that we're using for that. They're right there in that source. Okay, so we make the shader, check some things, set it. Now here's where we set the projection matrix with those variables we determined. So we take the negative half width and the half width. Those are the two sides. And then we take the negative half height, which is like the bottom, and the half height, which is the top. And let's just, our view matrix is just a model matrix. And that's mostly it for the setup there. The game code gets a little trickier. As you can see, I was playing around with the -1 to 1. Like we could see that. Okay, let's look at it how it is first, do a few resizes. Because if we resize this window, as you can see, these stay in the exact same spot relative. There's still 0, 0 in the center. They're still offset the same. So we don't have it like scaling with the window. So with this type of setup, you do want a fixed window size usually, and that's pretty common for older 2D games. Is that fixed window size, because the scaling can get really weird. Yeah, not sure if I'm saying that right. So it might, if you're gonna scale your window and want everything to scale with it, you might want to do it a little differently. But if you want it to be fixed so that it like plays the same for everybody, this would be the way. As you can see, that check mark stays in the center, but these are staying the same far away. And I'll show you that here in a second. So the only other thing we do here is, we set up our game code, and that's actually done somewhere else, which is in this game code. We'll go through that here in a second. Just want to show you the loop real quick before we jump out of here. I stopped setting the clear color of the background. I just left it black because it seemed easier to view the game that way rather than the blue we were using before. Alright, so we're doing a lot of the same stuff. We got a process. Okay, everything is the same. I'll only talk about the new stuff. So the stuff with demo 2D is stuff that's running our game code. Like we prepped up this 2D shader, which we might, in theory, if it was only for our game, we'd probably move all this to our like game stuff, but we're still kind of hacking around a bit. So it's just in here. So beginning of the loop, we check the player controls. That's so we can actually move. And then after getting the delta time, we do an update, giving it the delta time so that we can calculate physics and stuff. And then before we draw, we of course want to do a clear, use our shader, and then just render. So all the logic of all the movement is done in update, and there's a little bit of logic done in the render as well. All right, so let's take a look at our game code first. Let's go ahead and take a look at our objects. These are just the world objects. We have a location, a scale, a color, and a rotation. It's kind of a weird order because I added rotation last, and I didn't want to mess up my initializers, so I just plopped it there in the end. But usually I would prefer to have it something like that, but I just don't want to mess up my initializer list. All right, so, and we're going to look at the AABB collide. This is just a very straightforward collide code. Basically, we're looking at rectangles or squares only. So we just do some very straightforward logic here. You can find code for this online. The code I actually went off of was wrong for me, so I had to do some adjusting. So I basically, you take object 1 and object 2, right? Well, you'd want the left side, which is the location's right in the center, and then you have to minus the scale to go to the left or positive the scale to go to the right. So we're just checking the edges and making sure the boxes are, I don't know how to do this with my hands, but we just want to make sure the boxes, I have a diagram drawn, but whatever. We just want to make sure the boxes are inside each other. That's all this does. If they're inside each other, we return true. Otherwise, we return false. So we can check this collides with anytime we want. Just pass it to objects. It will return true if they collide, false if they don't. Pretty straightforward, but very common code. You could expand this to 3D by adding another dimension, and it'll work just as well. Now keep in mind that this doesn't take into account rotation. So if you're rotating your squares, and you're going to have to do something different, and it might be better to use something like sphere colliders in that case, which are pretty straightforward too, but we're not going to talk about them in this episode. All right, now let's check out the game code. This will be the last part. This is a little messy. I kind of just left it as it was once it was finally good enough, so keep that in mind. I went ahead and threw in a namespace, that way it's really obvious in our main when we're using this 2D code. It seemed a little better that way. I could, you know, in theory, we could also make this a class and encapsulate it all within a class or something like that, but ultimately it doesn't matter. As long as it gets the job done and is clear enough, that's fine. So we are going to hold a game state, and this is just so we can decide what to display and whether we want to keep updating the controls and things like that. You can either be playing, you could have either won or lost, and you already saw all those states. So we start out with playing, and we also have a struct for our player. We could put this in a different header, but it is very specific to this game, so I left it in here. So our player holds a speed, jump power, and object, which is just our body. So of course our player needs its own little body, and that's just another one of these. So just a way we can expand it. So we want our body, and then we have some logic for all the movement stuff, left, right, jump. This is just if you're moving left, if you're moving right, if you're jumping, and whether you're falling. So later you'll see that we set those as we press our hotkeys. All right, and here's some assets. These are just all the stuff on the ground. These are the 2 leftmost squares. This is the one you got to jump over. These are the 2 right side ones. You can't see 2 because they are lined up perfectly next to each other. And since we are using objects of size, let's see here, you know, -1 to 1, our plane is all ones. That does mean that when we scale, the second one here is the scale, it's going to scale on both sides 100. So it's actually 200 wide when you scale it by 100, because it scales times 1 on each side. If we were like 0.5, then it would actually be the width of 100, because it would scale half that on each side. Hope that makes sense, but that's something I had to like dig into a little bit as I was lining these up. So yeah, these are just all the floor and the things we can jump on, and I'm just calling those just the objects. Really, they're like the floor or something. It might be a better name. All right, and then we instantiate our player, which just goes off this struct, of course. Use an initializer list, and that way you can set your speed, you can set your jump power on the fly, so you can move these or change these as you get power-ups or whatever in your game if you want, and stuff like that. And of course we have our body, which we just initialize with a location, a scale. So we're just making them a little 15 by 15 box, and this that bluish purplish color. So that's our player initialized. And then we have a goal, which was that little green square on the right, and it's just that quick object code. There's its placement, there's its scales, and there's its color, mostly green. And then we have a couple last objects, and one of them is called the lost display. So if you lost the game, this is what displays. Now this is just 2 squares that are slightly rotated. As you can see, there's some rotations there that make the red X. As you can see, they're red. So I could probably format this code a little better. Looks like the auto format doesn't straighten out this here, but so whatever, I'll just leave it. All right, so that's the X, and this is that green check mark. As you can see, it's just it's got some logical placements to be a green little check mark. I had to like custom nudge it around till it looked perfect, but I think it looks pretty good now. And then we do have a reset, which just resets our player and sets the game state back to playing. So as you noticed, our game like reset once we got to the end, and that's all that is. All right, so as our game goes, and it just goes through this main loop here, we just go check player controls, update, render. Check player controls, update, render over and over. So we'll look at that in our game code. We check player controls, which is somewhere way down here. Here we go. So on a press of A, we say left is true. On releasing A, we say left is false. So we are checking the release to stop moving. You will just keep moving if you never release it. And yeah, we do that for the right as well, and we do it for jump. So that's all we have is left, right, jump. That's all we need at the moment for what we're doing. Now, in theory, you could think like, okay, maybe I want to swing a sword or shoot a gun or whatever. You could check last direction moved for which way you're facing and then do it in that direction and stuff like that. All right, so the jump is where it gets really tricky for the colliding stuff, at least for me, because you have to take into account the jump and like the gravity of falling. So I programmed that in here a little. I didn't make it super elaborate. I really just wung it, so it's kind of janky code, but as you could see, it generally works enough for like a quick demo. So if you hit the space bar, if you're not currently jumping, it sets jumping to true. Now I probably need like a little more logic like this, like player dot, I don't know, I need to make sure you're grounded. Like you can't jump if you're not grounded. So there could be a tiny bit more logic here to check that you're actually on the ground. But instead, I just did something a little different. I said, for the release, if you're currently jumping, then jump equals false. And this is so you can do small jumps. The longer you hold it, the higher you go. It's one of those systems. And if the player is not falling when you release it, then the player is now falling. But that also is within this jump. So if you were jumping and not falling, and then you start falling when you release it. And that's what gives it the customizable arc, which I will demonstrate again. So if I tap it real quick, just a little tiny jump. If I hold it, it goes way up until I let go. So quick little system there. Like I said, this isn't perfect. If you like want to play around, clone this and play around with it, you're welcome to make pull requests, and I will give you a shout out if there's anything cool that you add or make anything better, because this is just a one-man operation right now. And you know how one-man operations are. You always miss something. It pays to have a partner. And I don't really have a code partner in crime right now, so it's all me. Let's see. Okay, so yeah, that's the player controls. So let's check out the update, because that's basically where all the main logic happens. So with this update, of course, we took in that delta time so we could work with it. And the first thing we want to do is update the game state. So we want to know which one we're on. We have an end display length. Now I could put this somewhere else. This is just how long it shows that check marker X, and it's 3. So we have a little timer here too, just for to keep track of how long it's been going. That way we can time it. And I'm going to not talk too much about timers going forward, I think, because it's going to be a lot of repeating. There's a lot of timers involved. As you might guess, things have cooldowns. You don't want to be able to spam them, things like that. All right. So we check the game state. If you're playing, we just break out of the switch statement because there's nothing to do. We just continue on with the logic below. However, if we won or if we lost, then we start counting the timer. And if the timer exceeds the length, then we set the timer back to 0 and reset the game, which is going to call this function, set it back to playing, and reset the player position. So there we go. But majority of the time we're going to just break down to this bottom logic for playing. And one of the first things we want to do as we start this update, we're going to make a copy of the player's body. And the reason we're doing this is because in case we run into something, we want to go back to the previous position. Otherwise, we're going to end up inside of objects. So we just want to keep track of where it was before we processed all the update, basically. And now we have some quick jump logic. You can see here, getting the jump right is really hard. So I basically, well, we have a jump timer, which is basically how long you have been jumping for. And I've got it for a maximum time of 0.6. So if you're jumping and you're not falling, then it starts ticking up this jump timer, how long you've been jumping for. And I just hard coded it to 0.6 That seemed okay. So the maximum length of time you can jump for is 0.6. Otherwise, it's going to start making you fall, which we'll see here, right here. Falling equals true, and the jump timer is now 0. So otherwise, if you are still jumping, it just pluses your Y location based on your jump power and the delta time. Not the perfect jump logic, it's very floaty, a little weird, but it gets the general job done there. Okay, so if you're falling, we have some logic here too, and we have some timers because we need to do gravity. You know, you start falling faster and faster as you go. I didn't cap the gravity because it doesn't seem relevant in this small game. So basically we have a fall timer and we have a last fall velocity. We're going to use this last fall velocity a little later, so don't worry about it too much. But basically if the player is falling, well, we're going to hold our gravity constant, which I'm using 4.1. It's kind of a weird place to declare it, but whatever, it works. And we just, once you're falling, we start the fall timer and we just minus the player Y location by the gravity times the fall timer. So as this fall timer increases, it's going to be a bigger multiplier on this gravity and you're going to start falling faster. That's the whole point of that right there. And the reason we're keeping this last fall velocity is because we need to check the floor. Like as you noticed, you can actually walk off the edges without keeping track of like how far, I'm trying to think how to explain this. It's kind of weird to explain, but basically when you're falling, if you're falling really fast, you'll bounce back off the ground a little higher. It's weird. It's kind of awkward to get right. So anyway, if you're not falling, it just resets the fall timer to 0 because you're not falling. And that basically makes the gravity and speed of your fall reset. If we don't do this, every time you fall faster and faster, it'd be weird. All right, so let's check the quick movement. This is really simple. If the player is got their left or right set, we just move them in that direction, which is based on their player speed times the delta time. Pretty straightforward there. And then we check for new collisions. Check for new collisions. Now this is the more complicated of the code. It looks pretty straightforward here, but let's go through it real quick. So if we only want to check for collisions if the player is actually moving. So if player left or right or jumping or falling. So basically if they're moving in some way, then we're going to start doing stuff. So first of all, we create a Boolean called on something. Now this is like the whether you're grounded or not check. So we're going to assume that you're not on something at the start of every collide check. And if your player's not jumping and not falling and you're moving left or right, we want to check if you're still on the ground. We want to check if you walked off a ledge, if you're moving left or right, but you're not jumping or falling. So that's what all of this is. So this is where that last fall velocity comes in again, because I want to look at the player's feet. So I just declared a new object called the player's feet. I'm going to copy the body to start, and then I'm going to say the feet location is a little bit lower than our player. It's our last fall velocity. That way we don't accidentally chunk down a little bit like every one of these, like every check. Otherwise you start like just slightly chunking down and it's really weird. So you need to hold this velocity so you check actually below your player just a tiny bit to see if there's something below it. So that's why we got this last fall velocity. And then all we do is we just go through all the objects and see if they're colliding. And if we are colliding with something, we say we're on something. Now this doesn't check the left and right side properly, so you can like stick to walls, which is a little weird, but I just left it because I was like, it's going to take me a while to program in all the sides of everything. You know, I didn't want to go that far. So basically we just see if we're colliding with something. I guess you could assume that you're hanging on to a ledge, so even if you like land on a ledge, you can still clamp onto it. I don't know, maybe you're a lizard or something, I'm not sure, or a spider. So then at the very end we say, hey, if you're not on something and you're not jumping, then you're falling. So we set falling to true, which we work out a little later here. Then after all that, check for new collision. This here is actually, we should probably have more comments. We should do something like this. Should probably be right here. Check grounding. There we go. And this, once we get past all of that, the main thing we're going to do is be setting it whether we're falling or not, and this whether we're on something or not, which we'll use a little bit later too. Then we just want to do a general colliding check, just go through all the objects, check if it collides with the player on any of them. And if your player's falling, we want to, okay, so this is if true. If true, it goes into this. So if you're falling and you collided with something, then it sets you back to your previous player location, that location we saved, and then falling is now false. And your jump timer is now 0, which means you can jump again, basically. And if you're moving left or right, then it sets you back to the previous location. So if you did collide, it just sets you back to your previous location and resets variables as needed. And the last part of it, this is just the endgame conditions. It checks if you're colliding with the goal. If you're colliding with the goal, it's going to set game state to 1. And if you're colliding with, or well, if your location's less than -400, that's like a kill zone. So if you fell off the ledge, basically, then it's going to set it to lost. And we'll see those here in a second under render. So under render, we have a big switch for the game state. If you're playing, then we're going to draw all the objects, which is all the floor and the platform. And we're going to draw the player, and we're going to draw the little end square. So if you are currently playing, it basically renders the whole world, and it does that by, setting the model matrices. We're using translate and scale here. As you can see, first it translates, then it takes that result and it scales it, and it sets the color to whatever the color was, and it does that for all of them. So we could, in theory, move these around and stuff, but we're not going to do that. We're just leaving them stationary. And then, after we update each of them, we draw them with this draw strip, still just using that draw strip. So in another case, if you have won the game, then it just displays those two little squares that look like a check mark. So we have that, and as you can see, we now rotate. So we do the translate first in this case, and then rotate second. If you have a rotate, you need to do that second, and then scale. You can find these functions on GLM if you're not familiar with them. Translate's pretty straightforward. It's right there. And the rotate takes more stuff. Basically needs to know how much is the rotation and which axes, and then scales last, of course. So rotate will return something, and it's gonna take that matrix and scale it. So there we go. Translate, rotate, scale. Very good. And it's the same thing with lost, except this is a red X. So if you're in the game state lost, it's a red X. And based on that timer we were looking at earlier, way at the top of the update, seem to have lost it here. There's a lot of code. All right. Yeah, so if you won or lost, then it starts that end display timer and resets when it's done. And there you go. That's all the code. That's a little 2D game using orthographic projection, and that's showing you also how to do the aspect ratio stuff to keep it clean and easy to reason about. Now, there's probably a lot more to ortho, but I was just trying to cover stuff that's not covered in most tutorials, and this whole aspect ratio and actually making a 2D little platformer didn't seem to be covered. Another big thing people use this for is isometric games, so maybe we'll do a demo of something like that here in the future. But for now, just wanted to show you this one, and hopefully you can use some of this code in your game, or it helps you. Please let me know. If there's any other cool tricks or cool resources for orthographic projection, feel free to share those down below so we can all take a look. I do now have a Discord. It's been up for a little while, but if you're messing with code and stuff and want to share or just have questions, you can jump in there and chat with some other people who are interested in technology and code. And if you want to go the extra mile in supporting this channel, I do post some stuff on Patreon at least a couple times a month, and I'm very quick to answer any questions any patrons have. And you also get a special tier in Discord if you are a patron. I just want to say thank you all. Special shout out to the patrons of this channel for this month for helping making videos like this possible. They really do make this possible. So without the patrons, I would not hardly make videos ever. So I just want to say that it really, really, really does actually mean a ton, and really does help me keep going. All right, I'll see you guys in the next one. Thanks for watching. Matt for Code Tech Tutorials, over and out. Keep coding, and I wish you all the best.